Hello, everyone, and thank you for joining us today for this Codefresh live webinar. Today, we'll be looking at the differences between VM-based CI pipelines and Docker-based CI pipelines in terms of maintenance, upgrades, pipeline creation, caching, and speed. Our presenter today is Guy Sultan, Solutions Architect at Codefresh, and he'll be joined later on by Kostas Kapolonis, our Developer Evangelist, for our Q&A portion. We will be taking your questions throughout the session. Please submit them using the Q&A button on your Zoom toolbar rather than in the chat so that we can keep track of them, and then we'll address them all at the end of the presentation. This session is being recorded, and a link to the recording will be sent to you by the end of the week. Lastly, please remember to reference codefresh.io/events for upcoming webinars, as we have fresh and informative webinars for you several times a month. Actually, our next webinar will be in 2 weeks on Helm 3, so check that out if you're interested. So that's it for housekeeping items. With that, I will hand it over to Guy to start the presentation.
Thank you, Taryn, and welcome everybody. Thank you very much for joining. So as Taryn mentioned, today we're going to talk about the difference between VM, virtual machine-based pipelines and Docker-based CI pipelines. So we'll see the different approaches, and we'll compare according to different metrics like maintenance and management, caching, and installation of different tools and support. My name is Guy Sultan. I'm a solutions architect here in Codefresh. So I mainly help with technical demonstrations, installations, onboarding of our customers, running POCs, etc. And you have my email address here, by the way. So if you have any questions to me after the demo or during, feel free to send me an email, and I'll try to respond as fast as possible. So to go over the agenda real quick for today's webinar, we'll start by talking about Docker usage in continuous integration. So what does that even mean? Because when usually people saying that they use Docker in production, they usually mean that they use Docker as a deployment artifact. Today we're going to discuss something else of Dockerizing your tools and using them in CI. Then we'll compare the two different approaches of VM-based pipelines with Docker-based pipelines, where with VM-based, you have to pre-install all the tools and technologies that you need to use on your VMs before running the pipelines, where with the Docker-based, you are actually Dockerizing those build tools as pipeline steps. So it's less maintenance in that regard. Then we'll talk about upgrading tools. So let's say you have some application that is using a specific version of Node.js or Python. How do you then upgrade this tool to the latest version or to the version that you need in VM-based and in Docker-based pipelines? Then we'll see how to mix multiple versions of the same tool in the same pipeline. So for example, for things like matrix testing, where you want to test run a specific test with multiple tools in the same pipeline, how would you do that in the two different approaches? And we'll see if we have time, we'll also talk about how to create pipeline steps on the fly. This is something that is available with Docker-based pipelines. So for the demos today, and we'll have demos for each of these topics, we'll use both Codefresh and Jenkins. So we'll use Jenkins as an example for a VM-based CI/CD platform, and we'll use Codefresh for a Docker-based CI/CD platform. Another thing that you should check out is that we created a GitHub repository that contains all the demo applications and the CI pipelines for this webinar. So you can go and check it out. You can even open it right now and then follow along together with me in the webinar during the demos. So let's start with some theory. What are Docker-based pipelines? So as I mentioned before, Docker-based mean two different things, and 90% of the people, when they say they have migrated to Docker in production, they usually mean that they're using Docker as a deployment artifact, which means that they package their application as a Docker image, and then they deploy this image to their cluster or to ECS or anything like that. The other meaning is using Docker for build tooling. And that's not what most of the people think when they say that they're use Docker in production. And this is actually what we're going to talk about today. So Dockerizing your tools and then using them in CI pipelines. So what happened before Docker? And we like to call this the dark ages. So before Docker, this was a pretty complicated scenario, both for developers and for operators, but I think especially for operators, because imagine an organization that has multiple teams and uses multiple technologies like Java and Python and Node and whatever. And the operator in this company, he has to know everything. He has to know how to deploy Java applications, how to deploy Node applications, how to deploy Python applications. So each of the developers, each of the teams that creates a new application with some specific tool and wants to build it and package it and deploy it, the operator needs to have this knowledge. Now, after Docker came along, for the operator, this became much, much easier because now every application is then packaged in a Docker image. And as for the operator, he doesn't really care what happened before. He gets a Docker image. That's what he needs to deploy. And then he mainly has to know how to deploy Docker containers, which is pretty simple. And he doesn't really care what technology is running inside this Docker container. So that's again for using Docker as a deployment artifact. And that makes the operators much, much happier. But today, we're going to talk about adding Docker in another layer of that workflow, which is this part, as you can see here, Docker-based pipelines. And that makes not only the operator more happy, but we'll see why it can make the developers happier too. So if we said that before, the operators, once they started getting those Docker images to deploy, they didn't have to care about what technology is running inside those Docker images. For the developers, Dockerizing the build tools makes it easy, and we'll see exactly why right now. So imagine, we'll see the difference between VM-based and Docker. So before, let's think of your classic Jenkins environment where you have some virtual machine as your build node, right? As your slave. And this is where you're going to run your pipelines on. So in that case, you have to make sure that you have all the tools that you need with all the versions that you need for each of these tools pre-installed on this virtual machine. So for example, let's say one team needs a Java 6 and another team needs Node version 9 and one team needs Go, etc. So the operator has to make sure that all of these tools are installed on the virtual machine. And then the developer comes and they can create pipelines that, and these pipelines, they count on that the tools are already installed. So they can go and run Java commands and run Node commands, etc. After that, with Docker-based pipelines, the tools are dynamic. So behind the scenes, only Docker is installed. Nothing needs to be pre-installed on some host, on some build slave before. And then each pipeline brings the tools that it needs packaged in Docker images. So again, this is the main topic of today's webinar. The other approach of Docker as deployment artifact, of course, is also a very important topic. And we actually discussed this in other webinars, and we also wrote a lot of blog posts about that. So you can definitely check out codefresh.io/events or /blog to see a lot of information and data that we shared around that of Docker as a deployment artifact. But going back to Docker in CI/CD, comparing to VMs. So what happened to the build farm after Docker appeared? We now have, before Docker, this is a build farm with VM-based pipelines. So if you are working in a large organization, sometimes you have, like, let's say a Jenkins, not necessarily Jenkins, but I'm just talking about Jenkins because it's probably the most popular CI tool out there, and it's been around for years, and most of the people are familiar with it. Then you had a build farm with many slaves, sometimes 10, sometimes even 20 slaves. And these slaves, they are the build nodes that will run your pipelines. And as we mentioned, we have to make sure that we pre-install all the tools that we need on these slaves. And this makes the job of the operator pretty complex, because the operator has to then go and install all these tools. He has to manage all these virtual machines. And sometimes nodes has different versions of the same tool. So what happens is the operator would start labeling those slaves and then saying, okay, I have one build node that has this version of Node and this version of Java and this version of Go. Then I have another slave and this only has PHP with that version and Terraform as well. With Docker-based, this becomes much, much easier because all the slaves are exactly the same. Only Docker is installed on each of the slaves. So they are also stateless. You don't have to worry about installing things on them. So it's much, much, much easier to manage, and that makes the life of the operator much easier. But it actually also makes the job of the developer easier, because now the developer doesn't have to worry about which slave to choose when running his pipeline. So before, the developer used to think, okay, now I have this pipeline where I have to use PHP version 7.3 and Python version 2.7. This pipeline will not necessarily run properly on each of the build nodes. I have to choose the exact build node that will support my current tools with the versions that I need. And with Docker, the developer can run on any of the build nodes. And then again, only Docker is installed behind the scenes. He will bring his pipelines with images per step, and these images will contain exactly the tools that he needs with the version that he needs. And after the pipeline is completed, all of these tools will be reverted. The machine will be reverted to its original state, that where only Docker is installed. All the images and containers will be discarded, and the build node will come back to its original state. And I know that sometimes this might not be completely clear yet, but once we jump into the demo, it might make more sense. Another advantage of Docker images is that they are everywhere. They're reusable, they're shareable. You can get public ones in Docker Hub or in other public Docker registries. You don't need to reinvent the wheel. Like, for example, you need to use Terraform. So yeah, you can take the Terraform CLI and create a Docker file and to wrap it around it and then have a Docker image with Terraform. But you can just go to Docker Hub and search for Terraform, and obviously there's the official Docker image of Terraform, but you also find lots of other images that contains both Terraform and also other tools. So with Docker, you can always create your own private Docker images. You can create public ones, use public ones from Docker Hub, etc. So how does it work? With container per build step. So we said that with Docker-based pipelines, each developer will create a pipeline, and each step will run its own Docker image with the version of the tool that it needs. So if you look at this pipeline, for example, and again, we're referring to Codefresh in this sense, and I will explain exactly what is Codefresh in a few minutes, but basically it's a CI/CD platform that offers Docker-based pipelines. So let's say in the first step, I want to package and test some Node application that I created, and I need to run it on Node version 9. So all I have to do is choose the Docker image that has Node with version 9. I can take the official image from Docker Hub in this case. Then I can run the commands that I need to package and test my application. So npm install and npm test. Then let's say I want to store the test artifacts that were generated on the first step in my S3 bucket in AWS. For that, I can just bring the Docker image of AWS CLI and run AWS command to store my test artifacts there. And finally, let's say I want to deploy a Helm chart to some Kubernetes cluster. I can bring a Docker image that has the Helm CLI and then run the Helm command to deploy my application. So Codefresh can do all of that. Codefresh, as I mentioned, is a CI/CD solution, which is Docker-based. Every step then in the pipeline is a Docker image. It has native support for things like Docker, Helm, and Kubernetes deployment. And it also has a built-in Docker registry and Helm repository. So that's some cool things. But again, that will not be the main focus of this webinar. Now let's see our first demo. Let's say I want to have a CI pipeline that will package both a Node application that I have and also a Python application that I have. Again, you can see the applications here in this GitHub repository. So I have my GitHub repository here. I can click on this folder and I can see that I have my Node application here. And I also have my Python application here. Now to package both of these applications in Jenkins, for example, what I did is I have a Jenkins environment and I created two slaves, and these slaves are installed on VMs. You can actually see those VMs here in my AWS account. So I simply created two EC2 instances running Ubuntu in version 18.4. So one slave is running on this instance and one slave is running on this instance. Now I need to then install both Node and Python on my slaves. Now the easiest way to do that with Jenkins today is to do that using plugins. So if you go to manage Jenkins and then to global tool configuration, you can see that you can then configure different tools to be installed on your slaves as part of your pipeline's execution. So I actually went and created a Node.js installation, and I would need to use Node 11.1. So I chose this from Node.js org, and I named it 11.1. And I will then be able to add this Node installation to my pipeline. So I can go and click on my first pipeline, click on configure. Okay, I can then restrict the pipeline to run on which of the slaves that I want. So I can choose either slave 1 or slave 2, or I can uncheck this and then let Jenkins decide where I'm going to run my pipeline. I then connected my Git repository into my pipeline. Sorry, to clone it. And then under the build environment section, I can choose my Node.js installation. So by default, it will look for my Node.js installation on my VM. And if it's not installed, it will install it there. And then I can add two build steps. The first one will then go to the Node.js project as the working directory, print the Node version on that VM, and run npm install to package my application. And the second one will do the same for my Python application. So it will go to my Python directory and run a Python 3 -- version and pip install to package my Python application. Now I actually already ran this pipeline, and I can see that here I had one successful execution and one failed one. So I can go and see the logs of the successful execution. I see that it ran on slave number 1. So I can see here that it was able to print my node version, indeed version 11.1. Then it ran npm install, it downloaded the dependencies, packaged my application. And finally, in the next step, I was able to print my Python version and run pip install, and this was successful. Now let's see why the other execution was not successful. And I can see that here the node version, the node part, build step ran fine, but here with Python, it was able to print my Python version, but it failed to run pip install, and that's because pip was not found. And how could that happen? I see that here, this ran on slave number 2. So apparently pip was installed on slave number 1, but it was not installed on slave number 2. And here comes exactly one of the pain points of VM-based pipelines, that I have to maintain all of those VMs. And so the same pipeline ran properly on one VM, on one slave, but it failed to run on the other VM because it was missing some tool. And imagine that, again, this is a demo environment. I only have 2 slaves. In a big organization, you can sometimes find yourself with 10 or 20 slaves. So that does require some maintenance. Now let's see how the same thing would look like in Jenkins, in Codefresh. Sorry. So Codefresh is a SaaS platform. This is how it looks like. You can go and sign up for a free account. And here I created a project for this demo environment. And you can see that in Codefresh, the pipelines I created using a declarative YAML file. I can either build this YAML file inline or pull it from a Git repository. Now here you can see a classic example of using container-based pipelines. So you see here, I don't have to pre-install anything on any build node. I don't have to manage and maintain any slaves or VMs. I just create a step for packaging my node application. I provide a Docker image that has node with the version that I need. So in this case, the official image of node version 11.1. I can point to my working directory in my Git repository, and I connected my Git repository to this pipeline, and I can then run any commands in the context of that image to package my node application, and do the same thing then for Python. I created another step. I provide a Docker image that has Python with the version that I need, and I can run any commands in the context of this image to package my Python application. Now, if I look at the execution of this build, I can see that indeed the first step was able to run Node with the version that I need and package my Python 9 Node application. And the second one did the same thing for Python. So here I don't have to worry about, oh, I forgot to install pip on some VM. Behind the scenes, only Docker is installed. And for each step, you get a Docker image with exactly the tools that you need and the version that you need, and it runs anywhere. So that was the first demo for running both a Python and a Node application. Now, let's say I want to add additional tools. So with traditional VM-based platform, what you would do as a developer, you would say, okay, let's say now I need to use AWS CLI, or I need to use Terraform. If these tools are not yet installed on my VMs, on my slaves, I have to open a ticket to my operator and ask him, please add these tools to any of the build nodes. I will need to use them for my CI pipelines. And then you can see classic questions of VM-based platforms like, do you support my favorite version of Node or Java or Python or Ruby? Can I run Ansible? Can I run kubectl or Helm? Do you support these tools? And here you can see a real screenshot from a real platform and real tickets of users saying, please add Python 3.7, or please add Scala with this version. And here you can see the changelog of this company's platform, and you can see all the updates. Like here now, we added Ansible with this version. We added Docker Compose with this version, or Maven with this version. So they always have to worry about supporting new versions and adding more tools. Let's see how we do that in an example. So let's say I have the previous pipeline that we showed you before. I'm packaging my Node application, packaging my Python application. Now I also want to add a microservice that I created using Go, and I want to use AWS CLI. So again, I can go to my Git repository. I can go to the second folder, and now I see also a Golang example here, which will contain a little Go application. I can go back to Jenkins, and now I need to think about this. Okay, so I now in Jenkins want to also use Go. So what do I need to do? I need to go to Manage Jenkins and to go to Manage Plugins. And I already did that before the webinar, but I can look for Go. So I had to install a Go plugin. Then go back to Jenkins, global tool configuration, and add a new Go installation. So I would need Go version 171. I added such an installation. I set it to install automatically, and I called it 171. So now it should be good. And if I go to my second pipeline, I can click on configure. And again, these configurations are the same as before. So I'm cloning my Git repository, and I have my installation of Node, which I will still need. But here I also set up a Go programming language tool with the version that I need. So these two steps are same as before for packaging my Node application, my Python application, but now I also added this step for Go, and I added another step for using AWS CLI. So here I'm just going to my Go project in my Git repository and running Go version. And then I'm also running AWS minus version in this step to see that I have AWS CLI installed. So if I go and see the executions of this pipeline again, I see that I had a successful execution here. And this one ran on slave number 1. And I see that it packaged my Node application and Python. And this was also able to print my Go version and my AWS CLI version. And it ended successfully. But let's see why the other step, the other execution failed. So this one was also able to run Go, right? Because I added my Go installation to my pipeline. So it doesn't matter which slave it will run on, it will just install it every time if it will see that it's missing. But this one failed as AWS was not found. And how could that happen? I see that again, this was on slave number 2. So I forgot to install AWS CLI on slave number 2, and that failed my pipeline. Now I have to SSH into my VM that's running slave number 2, install AWS CLI on that on this machine, and then run it again. So again, we see an example of same pipeline that is running successfully once, but then it fails because I have to manage those VMs. Now let's see how this will look like in Codefresh. So as you might have guessed, with Codefresh, all I have to do is add an additional step that will run Go and an additional step that will run AWS CLI. And again, this step will simply have to provide a Docker image that is running Go with the version that I need, and then run Go version. And the second one for AWS CLI, I can just bring the official Docker image of AWS CLI and run any AWS commands. So again, I don't have to worry about what infrastructure it will run on. Make sure that I pre-install any tool on these on VMs or slaves or anything like that. Just add the Docker image that I need. And again, this is true if also I want to add any other tool, like let's say I want to use Terraform, I could have just added the Docker image that has Terraform CLI and run any Terraform commands. This is true for any tool that has either a CLI or an API that has a Docker image or can be easily packaged in a Docker image. So I can look at this execution here, and I see that here I used Node 11.1 and packaged my Node application, and this one used Python 3.6 to package my Python application, and then this step used Go with the version that I need. And finally here I used AWS CLI. Now an interesting point here is that you see that the AWS CLI image actually also ran Python 2.7. So without even noticing, we ran two different versions of Python in the same pipeline in different steps, and there was no problem. We didn't even have to worry about collisions or maintenance of two different tools on the same pipeline. As with Docker, every step is isolated and independent. So that was adding additional tools to my pipeline. Now you can think about a classic question is, does Codefresh support Node version 10 or Python version 2 or Gradle or Vault? Now the answer is yes, because we support everything that Docker supports, and as long as there is a Docker image for each of these tools or for each of these specific versions, then we support it. And the good thing about Docker is that it's future-proof as well. So imagine that now there's a new version of Python that comes out. Immediately it will have a Docker image, and you'll be able to use it from Docker Hub or from any other registry, so any existing image. But also if a new tool comes out, it can be used right away and packaged in a Docker image. So that was adding additional tools. Now let's talk about tool upgrades and version clashes, and this is also a very interesting topic. So before we said, okay, maybe we had a developer asking to add an additional tool. Now let's say I'm a developer and I need to use a newer version of Java for my application. So with a VM-based platform, I have to go to my operator and say, hey, please upgrade the version of Java. The current build node doesn't have the latest version. So I have to open a ticket. The operator then has to look and see how to install the new version, on which build nodes he should do it on. And then also he has the question of, okay, should I keep the previous version and just leave the new one? Or then I have to keep both of them and then maintain both of them. Maybe I will have one version of Java on this node and another version on this node. Then I have to label this slave with this label and the other slave with this label. And me as a developer, I have to choose which slave to run on, because one slave can support it and one slave cannot. And again, you can see a screenshot from real VM-based CI solutions of users asking, please add PHP 7.3, please upgrade Maven to this version. Or here you can see the other problem, or of older versions of R are no longer available. Maybe an operator upgraded a version of R, but he removed the previous version. And now maybe if my team still has a legacy application that needs the previous version, now I have a problem. So all of these problems are obsolete when you're talking about Docker-based pipelines. Now let's see specifically about Python, how we can upgrade to a newer version of Python. So we can go, and this can actually do it on the same project. So I think with Jenkins, you got the idea. Now I will have to go and log into my slaves and upgrade the version of Python. And then I will be able to run my application with Python 3.7. With Codefresh, that will be very easy because all I have to do is change the Docker image that I'm using in my Python step. So I can just remove this comment and comment this one out. And now the same step is using Python 3.7 and not Python 3.6. And that's it. And then I can just continue with my life and run my pipeline with the newer version of Python. So I don't have to log in to multiple VMs or write some script that will update all the Python versions in all the VMs. That's much easier. That's for updating a Python version. Now, using tools, the same tools from different versions, that can also be a big problem. So version clashes, huge pain both for developers and operators. As we saw in the example before with R, legacy projects are still in use and we still need to support old versions sometimes. And using the same, using different versions of the same tool in the same pipeline in VM-based platform is almost impossible, and we'll see why. And that introduces a new family of software, which is called version managers. So maybe some of you are familiar with them. NVM for Node or RVM for Ruby. There's also similar version managers for Python or Java. So these version managers are supposed to help you maintain and manage multiple versions of the same tool on the same VM. But this is actually introducing a new problem or a solution to a problem that shouldn't have been there in the first place. Because if you think about it, now you also need to worry about upgrading the version of the version manager. And maybe version manager, if you don't update its version, it will not support a new version of the tool that you need. So it's wasting effort and it's wasting time. It's tied to a specific technology and it requires its own maintenance and installation. You have to upgrade it also to new versions. So it's a pain. It's a pain. And you know, Python is a lot of people are talking about Python with different versions. A lot of people are still using Python 2.7 or 2.6, but a lot of projects are also migrating into newer versions of Python. So that's always like a notorious question of, do you support both 2.6 and 3.6 and 2.7? What if I want to use Python 2.5? So Docker is in a way replacing those version managers because version managers, as we said before, are specific for a tool. NVM is a version manager for Node. It can handle multiple Node versions, but Docker can help you with changing versions of any tool in any versions. You don't have to worry about that at all. And also its own version is independent from the tool. So even if you're using Docker version 17 or you're using Docker version 18, both of these versions will still support all the versions of Ruby and all the versions of Python and all the versions of Java. So you don't have to upgrade Docker to support a specific version of Node. You don't have to worry about that. So again, with Codefresh, as it works with Docker-based pipeline and Docker-based steps, we support every container ever made and every container that will ever be made in the future. So let's see how we can work with multiple versions of the same tool in the same pipeline. So let's see how we, why is that a problem again in Jenkins? So if you remember with Jenkins, you can go to manage plugins and you can go to global tools configuration. And here, for example, I did add 2 installations of Node. I have an 11.1 installation and a 9.3 installation. So if I go to any pipeline, I go to configure, I can choose the version. I can switch between the versions, right? But this version will affect all of the steps in my pipeline. So what if I want to use one version in one step and then another version in another step? And I mentioned that at the beginning, maybe for matrix testing, right? So that's a problem. It's not straightforward at all with Jenkins. Again, you might need to manually install some version manager on your node and then run some script or some manipulation to change the version inside of the build step. With Codefresh, you can just add another step. So let's say I have one step that is packaging my first node application. It's using node 11.1 and it's running npm install to package this microservice that I created. Then I can have another step and this one will package my second node application. And here I provided a different Docker image with node version 9.3. And again, I will run npm install. And so this will work with no problem. I don't have to worry about it whatsoever. And I can see it in action here. So this is packaging the first node application running 11.1. And this will package my second node application running version 9.3. So that's for multiple versions of the same node. Now I think this will be the last demo for sharing data between pipeline steps. So a lot of times we need to share data between steps. For example, a classic example would be, let's say you want to download some dependencies in one step, then you want to run some tests in the next step. Or you want to run some tests in one step, then you want to take the test artifact and push them somewhere else to present a report, right? So you'd have to share data between these steps. So the output of one step will be the input of the next step. How would we do that? So with VM-based solutions, there is the cache and artifacts configuration. So in some solutions, you would have to specifically specify which folders from which artifacts you would like to pass to the next steps. So the developers would have to define the exact path that they would need to archive. With Codefresh, what you get is a persistent volume for each pipeline. And then once, for example, you clone your repository, all of your project files will be placed on this volume. Once you download some dependencies, let's say you download node modules, they will be automatically placed on this volume. And then you can use these dependencies in any next step. You don't have to download them again. And for those who are familiar with Node or in general with the world of dependencies, that can save a ton of time because downloading modules can take a long time and you don't want to do that when you don't have to. So a classic example again with Node, how this will look like, and we'll show you a demo now, is that we will run npm install in one step and we can use the official image of Node version 9 to run this npm install step. This will automatically store all the Node modules on the volume that we get for this pipeline. And we can then run the next step of npm test. It can use the same Docker image of Node 9, and this will read the Node modules. It will not have to download them again, as it will be placed on the volume. Now, another cool thing in Codefresh, and we can show you that here, is that this volume is persistent. Now, first, let's see how we can do that in Jenkins. Right? And Jenkins has a pretty good solution for that, but it does lack some things, and I'll explain why. So with Jenkins, again, I can decide that I want to run this version of Node. I can have one build step that will run npm install. It will download my dependencies. Then the next step, I'm going to print this and see if I have these node modules folder and then run npm test to run my unit test. Now this should work fine, and indeed it did work fine. I can click on this execution and I see that I ran npm install, it download all of my node modules, and I could then run npm test, and I can see that my node modules are there, and it ran my unit test. It was successful. All is good, right? But this ran right on slave number 2. If I then run the same pipeline on slave number 2, then it will not have to download the dependencies again, because Jenkins has this concept of workspace. And if this slave already has the dependencies, it will not require me to download them again. But if I then run the same pipeline on slave number 1, it will again need to download these dependencies. With Codefresh, I can create a pipeline like we showed in the presentation, where the first step will have to run npm install to download the modules, and the next step will simply run the test to run my unit test, and it will depend on my modules. And I can see that the first time I ran this execution, this pipeline, it took about a minute. And indeed, if I look at the logs, I see that the first step downloaded the modules, and the second step, the node modules were already here, and I ran my unit test. But because the volume that we provision for each pipeline is persistent for that pipeline in Codefresh, if I look at another execution, a ladder execution that I have for the same pipeline, I see that this one only took 30 seconds, as even the first step didn't have to download the dependencies because they were already there. It used the same volume. So it can really shorten the pipeline time. And this is, again, not dependent on the actual infrastructure. So again, in Jenkins, if you have 20 slaves, 20 VMs, every time you run this pipeline, if it chooses a new VM, it will still have to recreate the workspace. With Codefresh, you don't have to worry about that. So now, just to talk generally about plugins, and those of you who are familiar with Jenkins know that Jenkins is a strong tool because of its plugins. There's a lot of plugins, and you really need a lot of them to use Jenkins successfully. Now, the problem with plugins for tools like Jenkins is that they are specific for the platform, right? So you have vendor lock-in, and you have to work with the Jenkins API. They are tied to a specific language as well, so you have to know Groovy in the Jenkins case to develop plugins, and you also have to know how to test and install them. With Codefresh, plugins are equal to Docker images. Each step is a plugin, is a Docker image. So it's very easy to create plugins. It's not tied to any programming languages like Groovy. All you have to know is some Docker knowledge. It's also then easy to test and search and store. And you can then use the same plugins that you develop for Codefresh as Docker images in any other tool locally, wherever you want. So we actually created a library of plugins. Each of these plugins are Docker images, and they are open source as well, so you can see how we develop them. These plugins are for popular use cases in CI/CD workflows, like performing blue-green deployment, like building Docker images, like pushing images to external Docker registries, etc. And you can also click on this link here to see how to create plugins for Codefresh at steps. So just to summarize, we reached the end of this webinar. We saw the different approaches between VM-based pipelines and Docker-based pipelines. We saw that if you need to add new tools with VM-based pipelines, you have to make sure that you install these new tools on your VMs. while with Docker-based pipelines, you just add another step and choose the Docker image that you would like to use. Same thing for upgrades. With VM-based, you have to make sure that you upgrade the tool on your VMs, on each of your slaves, while with Docker-based, you just replace the image with another Docker image that has the newer tool. Same thing goes for multiple versions of the same tool. This we didn't really cover, but we talked about plugins a little bit in Codefresh, which are simply Docker images. So thank you very much.
Awesome. Thank you so much, Guy. So we will go ahead and get to our questions now. So if you have any questions, you haven't entered them yet, please enter them in the Q&A using the Q&A button on your Zoom toolbar. Then we can keep them all straight. I want to make sure they don't get lost in the chat. So we will go to our first question we had earlier in the chat, actually. And I want to make sure that this is answered for everybody, whether Codefresh is compatible with Azure and AKS.
It is, yep. So if you go to Codefresh, and again, you can sign up for a free account and try this for yourself. But if you go to the account settings, first, we're completely Git agnostic. So you can use any Git repository that you have. If you're using GitHub, GitLab, Bitbucket, and we also support Azure DevOps as a Git repository. But we also support Azure as Kubernetes clusters. So Codefresh also has native CD capabilities, deployment capabilities to Kubernetes, and you can add your Azure AKS clusters to deploy your applications to Azure. You can add your Azure Docker registry to push images to Azure. So, yep, you can definitely do that.
Awesome. Thanks for showing that. Okay, this next question. Opening tool version selection to developers. In VM-based approach, at least sysadmins and infused have control in deciding based on vulnerabilities. Going with this approach of dev deciding tools and versions, how does IT keep sysadmins and InfoSec informed and handle security issues?
Good question. And that's a good point. So indeed, with Jenkins, how this works, and we talked about the disadvantages of that, where you are dependent on your operator, right? If you need to add a new tool to your VM-based platform, or you need to upgrade some tool, so you have to open a ticket to your operator. Now, I'm not saying that this is necessarily a bad thing, right? This is a methodology of the organization. Some organizations, they want to make sure that the operator has all the control, and he's in a way then becomes the bottleneck. But at least there is someone that is responsible, and not anybody can do whatever they want. With Codefresh, by the way, with the enterprise package, you can create teams of users, right? And you have a very flexible permissions feature, where you can decide which group of users has access to which pipelines, and also what kind of access. So by the way, you also see that in the scope of the clusters, as you can also integrate Kubernetes clusters and then decide who can then access those clusters. But in our case, we're talking about the pipelines. So for example, let's say that you have a pipeline that is more sensitive, as it contains a deployment step to production. You can say that only admins has access to this specific pipeline. You can tag pipelines with different tags, and then decide which group of users has which kind of access to these pipelines. So one approach can be only admins can create and update pipelines, while developers can only read or run pipelines. And this way you can still keep the power with the operators, but still lead them, make the job easier.
Thank you. And just since we're running close to the top of the hour, I'm just going to go ahead and launch a poll in the background. Please let us know what you think about the webinar. We're going to continue to answer questions through this, but we really appreciate your feedback. Okay, next question. With Docker, every Docker build creates new images, which consume space. How does Codefresh take care of that?
Good point. So first of all, Codefresh has a pretty unique caching mechanism, where Each time you run a pipeline, by default, it will use both Docker cache, and also it will use caching on the intermediate layers of the Docker image. So for example, if you look at this pipeline that I had here, that started with cloning my repo, building some image, then pushing it to some registry, and finally deploying it to production. You see that it uses the cache for building the image for every layer. So in terms of speed, that can be really fast. Also, every Codefresh account gets a free private Docker registry. And this Docker registry is not limited at all in terms of image sizes and number of images. So every image that you build as part of your pipelines will be automatically pushed to this registry. However, you can then decide which images you would like to push to your own registry. So you can integrate your own Docker registry that you use, like ECR or GCR or Docker Hub or JFrog or whatever, and then you can have some kind of logic in your pipeline saying you can have more like a dirty registry versus clean registry approach. Like you can have a dual registry, and then all of the images will be pushed to the Codefresh registry because it's free and not limited. But only images that pass specific tests or only on specific use cases, you will push them also to your own Docker registry. So you won't, fill it up with unnecessary images.
And BTR had one more question, and that was why the second test took nearly 50 seconds. And I think that was in your last demo, if you recall. If not, we can get back to him on that.
In Jenkins was that, or Codefresh? Let's see. Let's see. Maybe it's on the chat. Let's see.
Yes, it was in Codefresh, he said.
In Codefresh. Okay, so I showed that I had this pipeline, right? And this was the YAML file, right? So I first, in the first step, I downloaded the dependencies, then modules. Then in the second step, I ran the test. The test here took 7 seconds. I know why it's 50, but the total amount of time for all the pipeline was 30 seconds. However, in the first execution, it did take longer because the modules were not cached yet. So the test took about the same time, but the downloading the dependencies took more time in the first execution because it was the first time that they had to be downloaded. Second time they were used from the cache.
Perfect. Thank you for explaining that. Our next question, and we have a lot of questions here, so I'll keep going. If anyone has to leave, just remember that this is being recorded and I will send you a copy of the recording. So next question is, can you please point out some benefits of Codefresh possibilities against usage of Google Actions and other comparable solutions?
So I'm not sure what you mean by Google Actions. We do have a lot of comparisons that we did with different tools. So first of all, in this webinar, we talked about Jenkins. If you look for Codefresh versus Jenkins, for example, we released a very detailed comparison of Codefresh versus Jenkins and Codefresh versus Jenkins X, and also for Codefresh versus Spinnaker and other tools. So you can really look them up and see comparisons with the tools that you are looking for. Generally speaking, a lot of the CI/CD tools out there don't provide the same scope of features and functionalities as Codefresh does. So for example, that can be an interesting comparison. So if you look at, let's do, for example, Codefresh versus Jenkins and Codefresh versus Spinnaker, right? So Spinnaker, for those who are familiar with, is more for CD, right? So if you compare the different processes that you can do with Spinnaker, the CI part, like compiling, creating Docker images, running unit tests, you can't do that with Spinnaker. You need to use Jenkins. Then managing of environments and deployments, that we can do with Spinnaker. However, with Codefresh, you can do all of those things together because it has both CI and CD capabilities. So you don't need any third-party tool. You can handle both the deployment and the CI without custom scripts, as well as you have in Codefresh these dashboards that shows you what's running in your Kubernetes clusters, and see the endpoints, see the number of replicas, see the image, and then you can also have full traceability from code to cloud. That's one of the main advantages, I think. So you see this image that is now running in production in my cluster, I can relate it to the commit shard that happened in my Git repository and understand which commit triggered which pipeline that then built my production image.
Awesome. Thank you, Guy. Ruslan, if you have more questions, just communicate that through the chat and we can get back to you if that didn't answer your question. Okay, I have a few more questions here. Would Codefresh Docker be good for personal projects, a project that has one developer at most, per se?
Yes, for sure. So Codefresh pricing, by the way, is actually very easy to use and flexible. So every user gets unlimited builds for free, no strings attached, no credit card required in Codefresh. So if you have a very small team, you can start with the free plan. The two main factors that affect the price are the number of concurrent builds and the size of the machine that you will run the builds on. If you have just one developer, you want to develop your own project, you can really start with the free plan. You will be able to run only one build in parallel, but that's fine. You can start with that. And then in the future, if you need to upgrade to a stronger plan and run on stronger machines, or you need to have more parallel builds, then you can just do that from here, or you can talk to us and we'll help you up and fix you up with a tailor-made plan.
Thanks. And we have a few more questions here. I know we're at the top of the hour, but if you're okay to continue, Guy, we'll keep answering these last few questions. From Jason, I have, can Codefresh make API calls during a CI cycle? For instance, put an image to Docker Trusted Registry, part of Docker Enterprise, make an API call to initiate a vulnerability scan in DTR, and make another API call to deploy to the production cluster.
For sure. So what you can do, and by the way, you mentioned some interesting and useful steps to use as part of your CI pipeline. We actually created a lot of these predefined steps. So let's say you build a Docker image as part of your pipeline, then you want to run a security scan on this image. We actually created some native integrations as steps with some security scanning tools like with Aqua or Twistlock or Claire. So you can just add another step in your pipeline that will take your image, run a security scan on it, and if it finds any security vulnerabilities, then it can automatically fail the pipeline. So that's one thing that you can do. If you just want to send API calls, then for sure you can just use the freestyle step, and then see here, for example, it's just using the Alpine Docker image. You can use any image that has a CURL, right, or bash or whatever you need. And then under the commands, run CURL commands to send API calls as part of your pipeline. So you can have a step, like one step that will build the Docker image, then another step that will use the CURL Docker image, and will run API calls to any tool that you need.
Thank you. And our next question, can we capture UAT test case results in histogram or other related graphical form? For example, we use testng and can see how many times our UAT test cases passed or failed on the Jenkins console.
Good point, and I agree that's very important to see, and this you can actually see it very nicely in Codefresh. So we have a test report functionality which is based on Allure framework, and if you say that you use testng, then that's great because Allure covers testng as well. So any of these test frameworks can be covered. So I'll show you an example of running some Selenium tests in Jenkins pipelines. And then you can add a specific step that we created, which is called generate test report. So here I'm running some tests. Here it's with PyTest, I think, but it will be exactly the same with TestNG. Then you can add the generate test report step. It will then push your test artifacts into an S3 bucket or a Google Cloud storage bucket. And then you will have this test report button next to your build, and we will nicely visualize the results of your test inside of Codefresh, so you can understand exactly what happened there. And again, you don't have to leave the platform. You see everything from Codefresh. So both the builds, the test results, everything from here.
Awesome, thank you. And we have one last question. Is it possible to use conditions for the pipeline steps?
Definitely. And that's, I didn't touch that in the webinar, but conditions, parallel steps, and these are things that are very easy to do with Codefresh comparing to other tools. So if we look at a more complete example that contains both conditions and parallelism, you can look at this example. So for example, if you need to run some multiple Docker builds in parallel to save time, you can just use the parallel step type. And then any image, any step that will be defined under that will run in parallel. Then let's say I want to deploy some dynamic environment using Helm. That's what I'm doing here. And then only if it passed some test, I would like to then promote it to staging or etc. So I can look at the YAML part of this step, and you can see you can add for any step when condition, and then say only run this step if there was a pull request that was opened or reopened or synchronized, or only run this step if the previous step was successful, or if the previous step plus another step issued some results. So it's very, very flexible. You can do a lot of things with conditions. You can actually go to our documentation and look for conditional executions of steps, and you can see a lot of examples like run this step only if the branch is master, or run this step only if the branch is, you can use any regular expression to catch some naming convention. So a lot of different options for conditions.
Awesome. Well, thank you so much, Guy. Thank you to the audience for your excellent questions. A reminder to go create a free Codefresh account with unlimited builds at codefresh.io, and check out our next webinar, which is going to be on Helm 3, and you can go register for that one at codefresh.io/events. So thanks so much, Guy, and everybody have a great day. We hope to see you next time.
Thank you.